Hi, I'm Renat Manaspov, and in this tutorial I'm going to show you how the HVAC sizing tool works on a sample project. Let's assume that you need to size the HVAC infrastructure of the office building shown on this slide. The building consists of a few offices, a mail copy room, a spacious vestibule, and a couple of washrooms. The first and most important step in the HVAC system design is selection of the HVAC infrastructure configuration. For this particular building, you may say, Mr. Customer, I propose the following HVAC concept. The occupied areas, all the offices in the vestibule, will be served by a central air handling unit that will provide cooling and dehumidification during the summertime and humidification during the winter time. To compensate for the heat losses through the building envelope, we will install perimeter heating units along the exterior walls. The unoccupied spaces, which are the washrooms 114 and 115 and the storage 101, we will provide only perimeter heating units. The air handling system will have the following configuration. It will include an air handling unit with a supply fan, DX cooling coil, electric humidifier, central heating coil. Peripheral air terminals will be reheat coils that will provide individual comfort to specific zones, and every space will be equipped with baseboards located along the perimeter walls. All the heating elements, baseboards, reheat coils, and the heating coil will receive hot water from a boiler. Once the concept is approved, the HVAC engineer completes the following three general steps. Step number 1 is calculation of the heating, cooling, and airflow rate requirements for each element of the HVAC infrastructure, and to do so, he or she needs a software tool. We will be using the HVAC sizing tool. Step number 2, selection of the equipment make, model, and physical size based on the calculated heating, cooling, and airflow rate requirements. And step number 3, developments of the construction drawings that will be required to materialize the HVAC infrastructure. To size the HVAC elements, you need to gather a lot of information about each space in the building. You need to study the architectural drawings and measure the length of the walls for each space, to count the number of windows, to measure the floor area of each space, the roof area of each space, type of occupancy, and understand the envelope structure, the number of layers, type of layer material, and thickness. Once you gathered all this information, you can start loading this data into the HVAC sizing tool. Open up the tool and click on the tab Project. The tab explains how to use the tool. The modeling sequence includes 14 steps. Let's go through each of them. Input building and space related data. Go to the tabs General Data, Schedules, and Spaces. General Data, Schedules, and Spaces. Let's start with the General Data. In this tab, you need to enter the design weather conditions. You need to enter the exterior wall related information, the number of layers, material of the layers, and thickness. In a similar way, you have to enter information in regards to the roof. Search the architectural drawings on specs for the window characteristics and enter this data in this section. In addition, you also need to explain type of the floor and basement, if there is any basement, type of the windows. Let's pick, I don't know, recessed high efficiency LED trophy. The next tab, schedule, will require you to enter space utilization by occupants as the percentage of the peak occupancy in the space, lighting schedule as a percentage of the number of fixtures operating at a particular time of day, and equipment schedule. The next tab, spaces, will require you to enter all the data related to the space. And let me go quickly through data input, let's say for the office 103. You have to specify exterior walls. Go back to the drawing, find out the office 103. You can see that it has a northeast facing wall with 3 windows. The length is, let's say, 15 feet. So you enter the perimeter of the wall 14.5 feet or 15 feet, 3 windows, northeast orientation. The space has only one exterior wall, so you don't need to enter the data here. You also need to enter floor-to-floor height, floor area that you can also take from the architectural drawings, type of the floor, above conditioned space, slab on grade or below grade, type of occupancy. It's very important. It will define the default number of people in the space and the lighting density. You can also change this data later if you have more accurate data available. You also need to enter occupancy activity level. This selection will help to identify the occupant sensibly laden heating loads that will be later used to calculate the cooling load in this space. You have to pick type of space occupancy, lighting schedule, and equipment schedule. And of course you also need to enter the design summer and winter temperatures. The second step requires you to input system related data, and you have to use the tab Air System Input, located right here. Let's take a look at it. This tab allows to input up to 5 different HVAC system concepts. Let me remind you that at the very start we agreed that the occupied part of the building will be served by a centralized air handling system, and let's call it System S1. And the minor part of the building that includes washrooms, storages, and other unoccupied areas will be served by perimeter heating units, and let's call this system S2. First of all, let's input in the info related to the system S1. CAV or VAV means constant air volume or variable air volume system. We have a constant air volume system, so you need to select CAV value. The next 5 inputs allows you to configure the air handling unit. There is a heating coil, as we discussed before, and it's going to be served by a boiler plant. There is a humidifier that will be served by a direct electric heater. There is a cooling coil, DX coil. Reheat coils will be served by boiler plant, and space heating units also will be served by the boiler plant. The next set of inputs relate to the supply air temperature and humidity during the summer period and winter period. The next 3 inputs allows you to magnify the heating and cooling loads calculated by the code by a certain percentage to account for unforeseen heat losses or heat gains. Once you enter this information, you have to return back to the top project and see what's the next step. And the next step, number 3, requires you to assign spaces to specific zones and zones to systems. And to do so, you need to go to the tab zoning. Here is the tab zoning. First of all, let's define what a comfort zone means. It's a group of spaces or individual space served by a single thermostat. You may ask a question, why would you need, it's supposed to be one room, one thermostat? Ideally, yes. However, as a cost-cutting measure, the engineers sometimes group small offices or an office and a storage room together with one thermostat sitting in one of the rooms. To enter this information, you have to use your drawings. In this drawing, you can see that I allocated 4 comfort zones. Zone number 1 will serve these 4 offices, 105, 106, 107, 108, and a corridor with one thermostat and one air terminal unit. Zone 2 will serve just one room, one space, it's vestibule 112. Zone number 3 will include this part of vestibule, mail copy room, and this little storage all together. And there is another zone 4 which includes 2 spaces, office 104 and office 103. Let's go back to the tab. Here we go. Zone number 1, as we agreed, will serve offices 105, 6, 7 and 8. So you have to put 1 against all these spaces. And for zone 1, you need to pick the system that will serve this zone. In a similar way, you do zone 2, 3 and 4. And there is a zone 5, we didn't talk about it, but essentially it includes the unoccupied spaces, these 2 washrooms, and I allocated the zone 5 to be served by system S2. We need it for the consistency of the code. We need to, if you want to model the heating loads of the washrooms, you need to specify which comfort zone and which system serves these spaces. When you complete this tab, go back to the tab project. The next step is simulate design space zone and system level cooling loads and airflow rate requirements. Simply click the button Design Load Modeling. Now the code has computed all this information and populated in these reports. The next step is size, supply and return exhaust air ducts and fans. You have to use the tab ducts. Let's go to the tab ducts. To use the tab, you need to create a sketch of the ductwork in your building. Let's go back to the drawing. First of all, let's size supply air ductwork. Let me remind you that the mechanical room where the air handling unit is located on top of this floor, somewhere here. We assume that supply duct will penetrate through the ceiling of the floor, and then there is a main header duct that will be located here and serve individual zones. Zone 3 will be served by this duct, Zone 2 will be served by this duct, Zone 1 will be served by this long duct, and Zone 4 will be served by this duct. See, it's a very simple one-line sketch. There is a critical path that usually used to size the ductwork. It's longest path. Let's split it in sections So A to B is one section, from B to C is next section, the next section C, D, D, E, E, F, F, G, G, H, and from H to the air handling unit itself. Now let's go back to the top ducts. First of all, you need to pick the air temperature and the method of the friction loss rate calculations, and the rationale of this selection, as well as the rationale of other input selections in this tab and anywhere else in this tool, is beyond the scope of this tutorial. I would recommend you to take our course A to Z HVAC Design for Engineers, and that course will explain you all the rationale and details of how to design the systems. So let's go back to the duct tab. First, you need to enter the supply air duct sections in this column. Then you have to pick airflow rates for each section. Let's say for the section AB, if you remember, it serves the office 103, so you can borrow the result of the airflow rate simulation in the tab reports. Find out the report number 4, space ventilation supply air requirements. Here's the office 103. This is the value you're looking for. The next entry requires the size of the duct, the length of the duct, and duct material, which you have to enter manually, as well as some information on the fittings and duct-mounted equipment. In a similar way, you have to enter information on all other sections. When it's done, simply click the button Size Ductwork. The outcome is the velocity and friction loss rate for each section in the ductwork, and total pressure loss in each section, and total for the critical path. Once you are satisfied with the velocity and friction loss rates, you can calculate the supply fan effective power, calculate the sum of the pressure losses along the critical path, and input the airflow rate at the supply fan, which is this value. The result will be shown in this section. It's 0.21. Go back to the tab Project. The next step is adjust initial supply and return fan data based on the ductwork pressure loss if required. Go back to the tab Air System Input and see what the supply fan power input and return fan power input were originally used. If you are satisfied they're close to what you have calculated in the tab ducts, it's okay. If not, make them close. The value should be greater than the calculated effective power. Go back to the project and repeat the load analysis and supply computations again if you modify these two values. Go to the step 8, which is size central cooling coil. This is very simple, just click the button. Next step, size central heating coil, click the button. Next step, calculate building heating load breakdown, click the button. Size space heating units, click this button here. Size reheat coils, click the button. Next step, size heating and chill water piping and pumps. To do so, use the tab Piping. See, it says tab Piping. Go to the tab Piping. This tab works in a similar way as does the tab Ducts. I don't want to spend your time on this, but essentially you have to again input fluid type and temperature. You have to select the friction loss rate calculation method in a similar way, and all the information related to the critical path sections of the piping, and run the analysis. You would see the flow rates, velocity, friction loss rates, and the total pressure losses in every section It would also even have the fluid volume in all the piping, which is very helpful to calculate the expansion tank, by the way. Once you've done it, go back to the project, tap again, and the last step is size central heating and chill water plants, if you have them. To do so, click the button. There will be a prompt that requires from you to enter the number of boilers, let's say 2, click OK. When it's done, now you can use all the reports. There are maybe 24, I believe. Various reports that provide you information in regards to every element in the system. The most critical and challenging stage of the HVAC engineering has been completed. You have simulated the heating, cooling, and airflow rate requirements for each element of the HVAC system. And now you have the chance to select the make, model, and physical size of each element based on the simulated data. This step involves working with different vendors, manufacturers, catalogs, and the final step is drafting drawings based on the selections. Here's how the HVAC drawings look like after the drafting has been completed. You can see the main ductwork with the diffusers, reheat coils, perimeter heating units, the piping that you have calculated, and the supply and return duct goes up to the next level into the mechanical room. Here's the mechanical room floor plan and elevation. As you can see, it includes the air handling unit that serves the main area. There is a supply duct going down to the main floor. There is an outdoor air intake. Everything is sized and selected based on your computations. The floor plan includes the air handling unit, the boilers, and all piping and pumps. This was the final step of the HVAC system design using our sizing tool. I hope you enjoyed the video. To get more information on the tool and our training course, A to Z HVAC Design for Engineers, I encourage you to visit our website www.hvac-academy.com. Thank you for your time.